So once again, we shall start with the remaining aspect. There is one point that is left, is the organic precipitant. But before this, I would like to recall certain points of interest from the part that we have already studied. In the beginning of this topic, we have studied the process of gravimetry. It is a quantitative analysis technique. Then we have studied about 9 important terminologies with the respective definitions. Then we have studied the characteristics of precipitate, the conditions of precipitate, the physical forms of precipitate, the co-precipitation and the post-precipitation. So this much part that we have covered so far. Now we have to study the organic precipitants. Perhaps you might be remember that during your BSc 1 level, you have conducted one experiment that is known as spot test analysis, wherein you have used certain organic reagents which are known as the spot test reagents. All these reagents which have tendency to form extremely pronounced colors with a specific metal ions, hence they are known as a chelating type of reagents. These organic reagents find extensive application in chemistry. The peculiarity of these organic reagents is that by using a very minute quantity of the substance under analysis, we can detect the presence of any basic radical or any basic cation that is present. So for this analysis, by using organic precipitants, no equipped laboratory is required, just few chemicals are required so as to carry out such type of analysis, which is carried out with the help of organic precipitants. So the organic reagents which yield sparingly soluble and often colored compounds with one or more inorganic ions or inorganic cations from the mixtures are referred to as organic precipitants. In this regard, I would like to refer one organic reagent, that is a dimethylglycine, which is a selective precipitating reagent for nickel, which gives a rose red color with nickel. I am going to show you the chemical reaction with nickel and dimethylglycine. These are the organic compounds which have a tendency to form a precipitate or a color reaction with inorganic cations or the metal ions or the anions. These substances, they can find important applications in inorganic analysis, namely gravimetry, titrimetry, colorimetry, chromatography, spot test analysis, etc. A large number of valuable organic reagents belonging to almost all types of organic compounds have been suggested for this purpose. These organic reagents, they can precipitate majority of the metal ions from the periodic table also. Some typical illustrations that I would like to give you as a dimethylglycine, which is referred as a DMG. This dimethylglycine is a very important organic reagent. It is used in inorganic quantitative as well as qualitative analysis. For example, if we want to carry out gravimetric estimation of nickel, then dimethylglycine is used. So this is a quantitative analysis. Or if we want to carry out a spot test analysis, then we can use the same reagent. It is useful for the detection and the estimation of nickel even in the presence of cobalt. So if interfering radicals are present, such as cobalt with nickel, then DMG preferentially precipitates nickel from this mixture. It is a white crystalline powder, melting point about 236 degrees centigrade, molecular weight 116. It is insoluble in water, so DMG solution is to be prepared always in 1% alcoholic solution. So when this dimethylglycine forms a complex with a nickel, a rose red color or what we call a scarlet red colored precipitate that is obtained. I would like to show you this reaction with nickel, which is a very simple. Just take a look at this reaction. The dimethylglycine, which is abbreviated as a DMG, it is having the composition as CH3, C double bond, NOH, again CH3, C double bond, NOH. This is nothing but dimethylglycine. This is structure. When nickel solution is there with nickel, it can form a complex like this. Nickel is chelated at the center, that means it is coordinated or it is trapped, and these are the nitrogen atoms from dimethylglycine. C, CH3, double bond C, CH3, again double bond C, CH3, double bond C, CH3. So this is a structure of this OH, and this is again OH. So this is a structure of nickel dimethyl glycosymatic complex, which is having a rose red color or a scarlet red color thus obtained. So this is how dimethylglycine can be used to treat nickel. Second organic reagent is known as oxine, which is known as 8-hydroxyquinoline. 8-hydroxyquinoline is having the structure like this. This is having the hydroxyl group. This is known as oxine, which is particularly used so as to detect aluminum. A silky white precipitate that is obtained when oxine is treated with aluminum. So this oxine, it is a reagent commercially known as oxine. It is used for the determination of aluminum. It solution in alcohol or in dilute acetic acid act as a reagent. So this oxine can be prepared out of acetic acid or in alcohol also. It precipitates almost every metal from the periodic table except S-Brock elements, that is alkali and alkaline earth metals. It is a pale buff color crystalline compound with a molecular weight 145 and melting point which is very low, 76 degrees centigrade. Here with a bivalent metal ions, that is for example Mg plus 2, it is a bivalent, or Ca plus 2, it is a bivalent. The composition of the complex is like this. M stands for metal, C9H7O9 twice. And with the tetravalent metal ions, it is having the composition as MC9H7ON4. For the estimation of magnesium, 2% solution that is prepared in acetic acid, and it is used for the detection of magnesium, that is a divalent ion which can form a complex like this Mg C9H7O and twice. Now, what are the advantages of these organic reagents? First advantage is that these organic reagents is having very wide range of selectivity. Second is that the color that also very important, that is produced with specific metal ions. Third is ease of drying. That means we can dry whatever the product thus obtained very easily. Then here we have a freedom from co-precipitation. That means the contamination due to co-precipitation does not take place. That means whatever product obtained, it is free from impurity. And fifth is it is also used in volumetric analysis, that is titrimetry. Now, what is this selectivity? Selectivity means these reagents are very selective. When one precipitating reagent precipitates, only one cation or only one anion it can precipitate during the mixture. Such specificity is known as the selectivity. So it is very selective. Just now we have seen, if a mixture of cobalt and nickel is there, when we add DMG, then DMG can only precipitate nickel from the mixture. So DMG can select only nickel from the mixture and it can form nickel dimethyl glycosimetry complex. This is known as a selectivity. Second, that is a color. Most of the precipitates, those are obtained with organic reagents, have characteristic intense color. Just now we have seen that for nickel, rose red color or scarlet red color that is obtained. Third is that the ease of drying. That means the precipitates or the products thus obtained by using organic reagents, those can be easily dried. Then the fourth, freedom from co-precipitation. That means contamination due to co-precipitation that is avoided. As the precipitates are not ionized, they do not co-precipitate impurities from the solution. And sometimes these organic reagents are also used in titrimetry. Many precipitates can be dissolved in acid, and the liberated organic reagent may be estimated oxidimetry. For example, titration of oxygen with bromine. So if we want to determine the content of bromine, then we have to use oxygen as a titrating agent, or which is known as a titrant. So this is how these are the characteristic features of all the precipitates. So with this, I would like to conclude with this theory of gravimetric analysis. I will post the notes of the acids and bases non-aqueous solvents in due course of time, including the topic of gravimetric analysis. So thank you very much. Today we shall stop here.